Good morning, everyone. Once again, we're going to kind of work through a lesson today. Kind of the continuation of a periodic function, but now we're going to kind of label it by looking at the sine of x and how the graph is actually designed. Okay. For overall today, I'm going to be posting 3 different videos on it. Basically, 3 main points about this section. The first video is going to be about us understanding what the graph of sine of x looks like. The second video is going to be us looking for the amplitude. And last but not least, the third video is going to be us trying to find the period of the function. However, to really start any of these sections, to really understand the graph of sine, we have to look at it and really start building some small details about it. Okay. Before we can do this, we have to start analyzing this unit circle. Okay. Understand, anytime we're dealing with sine in a unit circle, that is just telling us to use y values. Sine applies to the y values of the unit circle. So, for example, in past lessons we've talked about this. Sine of 0 is just going to equal 0, because if you look at the 0-degree mark, your y value is 0. Versus sine of 90 is going to equal 1, because if you go to 90 degrees, your y value is just 1. Okay? Now, with that being said, we have to understand what a circle does. Okay? At some point, you're going to go around the circle. At 180, you'd have -1. At 270, you'd have, excuse me, oops, sorry about that. At 180, you would have 0. At 270, you would have -1. And then eventually you reach back to 0. So you're going in this constant rotation with all your y values. Okay? Well, because of that, at some point, you're going to start repeating. After you get to 270 down here, at some point, you're going to get back up to 0, and then it's almost like you have to restart your graph. Okay? This is why it's periodic. A circle is continuous, and then it can keep going around and around. Okay? This causes our graph up here to be periodic. Okay? And I'll kind of show you how in a second. Now, we're going to use a couple of tools to really analyze this. First off, if you notice this graph off to the right here, this one right here, these are actually all the values if you plugged it in and got your y coordinate. Okay, for example, if you plugged in a 0, you would get an answer of 0. Okay, and so forth. These are all the actual coordinates for sine of x. Now, we could basically turn these into an actual coordinate on each of our planes. Okay, for example, this is just the coordinate 0, 0. Versus this one is pi over 6, 1/2. Okay? And with those coordinates, we can plot it on the graph here. And so on this graph in front of us, we do have y equals sine of x. Okay? With that being said, let's analyze a couple of things. First off, we have a couple of zeros. It starts at 0, 0. At pi, we have a 0. And at 2 pi, we all have zeros. Okay? That goes directly in line with our unit circle. At 0, we have an answer of 0. At 180, we have an answer of 0. And then a full rotation would bring us back to 0, which is an answer of 0. Okay? Next, we have a couple of key points here. For example, we have an answer of 1, and we have an answer of -1. Okay? Those are our max and our mins. That's the highest and lowest points this graph gets. Because of that, we can assume our amplitude right now just equals 1. Because if we look the highest point from our midline, which our midline is right now directly in the middle, if we count 1 up from our midline, we're at the highest point. If we count 1 down from our midline, we're at our highest point. Okay? And we have a midline at y equals 0. That is the middle of the graph. Okay? Now, one of the things I kind of like to do is go back to the other lesson. Excuse me for erasing a lot of this. I just kind of want to just like almost design it for us. If you think back to the other lesson, we want to talk about like how long or how big a graph is. Well, we always want to include one max and one min. So if I do that box method from the other lesson, I'm going to draw my box, my starting point 0, 0. So I want to think, how big do I have to make this box to include a max and a min? Well, if I go all the way to 2 pi, technically that box includes both max and a min.